Hi, my name is James Giles, and I did a statistical analysis on how surgeons' experience affects simulated surgery results. So here's my introduction. I'll start off with some project background. Surgical simulations allow surgeons to test their expertise and gain experience for future surgeries. Simulations allow for practice without life-threatening damage. There were two previous studies done by a group of computer scientists and doctors. Um, they were done on the steadiness of a surgeon's hand and the arthroscopy shoulder surgery. Um, each one of these surgeons took a pre-surgery survey. There were 10 in the arthroscopy surgery and 23 in the steadiness of the surgeon's hand. Um, in the pre-surgery survey, they were they answered questions such as age, gender, hand dominance, medical experience, and game experience. These surgery simulations were then performed and data was collected. Um, then they took a post-surgery survey to validate the surgery's accuracy. The post-surgery survey just asked questions on how accurate the feeling of the surgery was with the haptic feedback, as well as the tasks to make sure that they were accurate with um, the literal surgery that the surgeons have actually performed. So a little description of my project is the goal of this project is to determine how a surgeon's previous experience affects a surgery's results. The purpose is to make sure simulations accurately show real results that reflect the true skills of the surgeon. My primary question was, how does a surgeon's experience affect simulated surgery results? Um, I had sub-questions within that. How does previous gaming experience correlate to simulation results? How many previous surgeries makes a surgeon an expert? My original third question was, how often does a surgeon need to perform a surgery to maintain the skill level that they have? But this question was not relevant to the data that I had, nor to simulations in general. This question would be better off answered with legit surgeries and legit surgeons without any simulation. Um, so I just created the following question, which is there a higher correlation between total surgeries performed and simulation error, or surgeries performed in the last 6 months and error? So a lot of these questions I had to adjust. Um, even the second question I had to adjust, which you'll see later, to um, fit the data that I had. So the outcome of the study was supposed to show what previous experience affects surgery results and how. It was supposed to result in clear evidence of what needs to be adjusted to yield true simulation results. And it was supposed to allow for adjustments and better training for the surgeons. So here is the materials and methods that I used. Here you can see the pre-surgery survey for rotator cuff arthroscopy surgery. In this pre-questionnaire, they asked age, gender, hand dominance, previous medical experience, how they would rate their hand skill level on a scale from 1 to 5. So their hand-eye coordination, approximately how many surgeries they have performed. Um, then in the last 6 months, how many have they seen and seen in the past 6 months? They also were asked about their video game experience, whether they consider themselves active gamers or not, and if so, how many, what is the average amount of hours spent weekly playing video games. So I started off with a bunch of separate data files of the pre-simulation survey, the post-simulation survey, and a bunch of haptic data, all out of order. But then I compiled all of this and all of the relevant variables that would be useful for this project into one file. As you can see below, these are the variables that I chose. Um, I left most of the pre-simulation survey questions that were answered. Um, the most important ones for me were um, their skill level, their how many they performed, how many surgeries they performed, how many they performed in the last 6 months, their virtual reality simulation experience, their virtual reality in general experience, and then their gaming experience, as well as the total amount of hours, which I changed this from ranges that they had, which were like 101 to 500, 500 to 700, and I mean 500 to 1,000 and 1,000 plus. And so what I did was, if you had 0 total gaming hours total, then I just put it at 0, of course. Then from 100 to 500, I moved that to 1. 500 to 1,000, I put that as a 2. And 1,000 plus, I put that at 3. So then I kept the total error, which was one of the most important ones for me, and total time. And then I went to the haptic data and I took the mean tool velocity, mean camera jerk, and mean camera acceleration and mean camera velocity. So throughout the entire simulation surgery that they performed, this haptic data was tracked and the mean of all of these variables were taken for each one of these surgeons. And this basically shows the steadiness of their hands and how how quickly they work, and the possibility of torn tissues um, and damage. Okay, so each surgeon had an ID, and they answered their pre-surgery survey questions, and the data was collected, as I was just explaining. So for the first question, I used the Welch t-test, which allowed me to do this on a sample size under 30, which my sample size was 10. Um, my question was, how does previous gaming experience affect simulation results? The sub questions were, how does gaming experience affect error? How does gaming experience affect time? How does gaming experience affect haptic feedback data? And I asked the same questions for the virtual reality experience on error, time, and haptic feedback. For the second question, I used Pearson correlation to answer how many surgeries makes a surgeon an expert, which I had to change just to the correlation between rotator cuff surgeries performed and the error, as well as rotator cuff surgeries performed all time to the time. And then I also did the correlation between time and error. So somebody who took a lot of time to do the surgery um, was most likely not an expert, and therefore they were more likely to have errors. So for the third question, is there a higher correlation between total surgeries performed and simulation error, or surgeries performed in the last 6 months and error? So I started off with just doing the correlation between the total surgeries and error, which I did in the last question. And I did the correlation between surgeries performed in the last 6 months and error. Then I did a linear model to show the relationship between error and both total surgeries and surgeries performed in the last 6 months. So here are my results. For question 1, with the same data set of 10 surgeons and only 2 that claimed to be gamers, I ran a t-test on total error and if the surgeon was a gamer or not. Here is the default Welch t-test of gamer versus error. And as you can see, my p-value was 0.7. Therefore, we didn't have any evidence against the null hypothesis. The mean error in the group not gamer, so people who were not gamers, was 1, and the mean error in group yes, that they were gamers, was 2. My data did not properly reflect this since there was only 10 surgeons total. The issue was that out of those 10, there were only 2 gamers, and both of those gamers did not have previous experience in rotator cuff surgery. So one thing that um, was kind of amazing is that one of these did get 4 errors, which was the worst out of all of the surgeons, which is expected for somebody who doesn't have experience in rotator cuff surgery. But the amazing thing is the other gamer didn't have any errors at all. So they perfectly performed the surgery in a small amount of time. So even though um, the data and the statistics doesn't allow me to prove against this null hypothesis, I do believe with a bigger data set that it is possible that this is true, which I would love to perform later on when I have a bigger data set. But all in all, there wasn't enough evidence against the null hypothesis for gamers and haptic data either. So I ran this on haptic data as well as error, and neither one of them proved to be significant. So for the second question, with the data that I had, it was not possible to answer the exact amount of surgeries that's necessary to reach an expert level, but I performed a Pearson correlation test on the amount of surgeries performed with the total error and time taken. So I did my correlation test on the rotator cuff surgeries performed and the total error, which yielded me a negative 0.1976 Pearson correlation. And then I did the rotator cuff performed against the time, and that gave me a 0.47, which was a little bit better, but still not significant enough. Neither of these were enough to prove correlation. So then I did a correlation test on the total time and the total error, which gave me a 0.58, which was good. There was correlation between time and error, which was expected. As I explained before, the longer you take means that you don't know how to do the surgery. This is new to you, and you're more likely to perform more errors. So for the third question, which was, is there a higher correlation between total surgeries performed and simulation error, or surgeries performed in the last 6 months and error? I did 2 correlation tests using the test from the last question, rotator cuff performed to error, and then used rotator cuff performed in the last 6 months to error. So the correlation test that I did in the last question is here, which was 0.1976 with the rotator cuff performed and the total error. Then I did the rotator cuff performed in the last 6 months to total error with a correlation of 0.2729, which is a little better, but still not enough. Neither one of these were significant, but I still decided to run the multiple regression on error with these two variables just for practice sake. So you can see the code here. I ran the summary function on it to give me more feedback. The residual standard error was 11.78 on 7 degrees of freedom. Multiple R squared was 0.4082, and adjusted R squared was 0.2392. The F statistic was 2.4 on 2 and 7 degrees of freedom. And the p-value was 0.1594. And as we can see, the p-value shows us that there is not enough evidence against the null hypothesis, which seems to be the conclusion of this entire project. So for the most part, I did not find anything statistically significant with the data that I had. I believe that this is due to the small sample size that I had, which was only 10 in the arthroscopy surgery. I believe with a larger sample size, the answers to the questions that I posed and similar tests done will yield real significance. Having only 2 true gamers within the data of 10 surgeons, and neither one of them having a high level of surgical experience or even experience at all, neither one of these gamers had performed any rotator cuff surgeries previous to this. They did have simulation experience and they did have gaming experience, which was able to help one of them succeed in this surgery, but one of them had the most errors as well. So it was the two sides of the spectrum in this data. So that was what I believe is the downfall of this project and this study that I did. I really do believe that with a larger data set and more gamers who were either experts or at least had some performed surgeries previous to coming into this study, that these hypotheses would prove true, that gaming experience would affect the surgery simulation. Um, I believe that there will be um, correlation, and um, the study would prove significant. All in all, this project was helpful to brush up on skills that were taught in class and help me apply them. Um, Using the linear regression and using the correlation, the p-values and the t-test, um, it was definitely um, good to put into practice and to study something that I'm already studying um, when it comes to research. So to apply these statistics to this will definitely help me in the future when I need to analyze data, which I will definitely need in the future. So I do appreciate this project. All right. Thank you.